Assalamualaikum and good evening. Today we are going to continue our next module, Module 9, FHRP Concept. FHRP stands for First Hoop Redundancy Protocol. Okay, this topic are regarding routing and gateway. Okay, in this module we are going to take a look in general what is a First Hoop Redundancy Protocol. Okay, there are two topics that we are going to take a look today. First is a first hoop redundancy protocol as a general. How we are going to use a one protocol in order to provide an access to a multiple device as a gateway. That's the objective of first hoop redundancy protocol. And one of them actually is a HSRP provided by the Cisco. Okay, 9.1, our first topic, first hoop redundancy protocol. Implementation of a one gateway, there is a limitation. If there is something wrong, something happened to our gateway, okay, so our device will not be able to reach the network, even though we might deploy multiple gateway inside our network. But on the router, on the client side, they are only able to configure with one gateway, only one default gateway. So they cannot switch or change to other gateway if the first gateway have a problem. So in order to cater for this problem, Cisco introduced, or the network engineer introduced one protocol to cater that we call as a first hoop redundancy protocol, which is the mechanism that provide alternate default gateway in a switch network where two or more routers are connected to the same VLAN or same LAN. So we have implemented R1 and R2 as a gateway, but at one time there are only one default gateway. So they are able to switch between these two routers as a default gateway. So with the implementation of one gateway, there is a one point of failure. If the gateway fails, so the whole VLAN can access the network. So in order to provide them to access the network, we need to introduce a new router, a new gateway. Then we need to reconfigure our client. So it's gonna take a time, and the client or user must wait until the action has been taken. In order to improve that, we are going to make the process happen automatically by introducing first hoop redundancy protocol. Okay, for the gateway, we will use the same IP address and same MAC address, even though we are using more than one router. So how can we achieve multiple router with a one single IP address and one MAC address? So in order to do that, we're gonna use a redundancy protocol. So this is the example. Let's say all the devices inside this router are using, they doesn't put any label here, R1 as a default router, default gateway. So once our default gateway have a problem, so they're gonna switch to another gateway, another router. So you can see the step here. If the router fail over, our first router fail, so the standby router will stop seeing hello message from the default router. So for all the router that we implement inside the network, they are going to talk to each other. They are going to send hello to each other periodically. Every 3 seconds, they are going to say hello. Hello, I'm alive. I'm a default gateway. Hello, I'm a default gateway. Hello, I'm a default gateway. So the other router as a standby, if they do not receive a sequence of hello from a default router, they will take over as a default router. But from the point of view of a user, they will never know there is a transition between router 1 to router 2. All the devices here we see as they always use the same default gateway, same IP address, same MAC address. So for first hoop redundancy protocol, as a general, there are many implementations. First, we have a hot standby router protocol provided by the Cisco. So this protocol are only able be used inside a Cisco router only. So if we are using both Cisco router, two Cisco router, we can use hot standby router protocol. But if we have other router, let's say router 1 is a Cisco, and other router is from other vendor, we can use the open standard like VRRP version 2 or VRRP version 3. Okay. So we go to HSRP. So we are going to configure our Cisco router with a HSRP. So HSRP and HSRP version 2 for IPv6. Okay, we are able to deploy multiple router, but they will take one router as an active device and they will be used for routing the packet to other network, and the other router will be in the standby mode. So when the active device fail, so the other router will take over. That's how HSRP works. So if we implement multiple router, in order to be accessed as a single device, I mean all the client here should see as a one device, 1 and 3 only. So both this router, router 1 and router 2, we use a virtual IP address and a virtual MAC address, even though that particular router have their own IP address and MAC address. Let's say here router 1 with the IP address of 172.16.10.2 and router 2 172.16.10.3. But we are going to implement a virtual router, so a client doesn't need to change or to switch between router 1 and router 2 as a default gateway. So inside the client, we are going to set one default gateway only with the IP address of virtual router. And that virtual router actually supposed to go to router 1 or router 2. So in this case, we pick the IP address of 172.16.70.1 as a virtual router with a MAC address of 000.0C07.AC01. So all the clients we see, they are always connecting to one default gateway only. So how we can pick one router as a active router and the other as a standby? Okay, by default, all these routers have a priority of 100. So in order to be an active router, to be selected as active router, we should configure them it as with a priority more than 100. The priority can be from 0 to 255. So we can change router 1 to priority 150, let's say. So it will be active router. So the other router will be standby router, or you can reduce the priority number of other router. Based on the default is a 100. Whenever a router has been elected as an active router within a network, a LAN, they will permanently pick until they fail, even though their priority number is lower. Let's say router 2 has been picked as an active router. Even though router 1 come in later after that with the priority number is 150, router 2 will stay as an active router until router 2 fail, and then router 1 will take over. So how we can set our new router with a higher priority as an active router? We can do that by issuing a command standby preempt inside the interface command, interface of that router with a priority with a standby. Okay, for the HSRP, the command that we need or we going to use actually a standby. There are several states when we start or we implement a HSRP. First, the start is an initial. The state enter through configuration change when interface become available, when we create the virtual IP address. And they turn to learn in order to determine if there is other active router. If there is no active router, so that router will be an active router. And at the same time, after that, if they cannot be an active router or they change into a standby router, and they will put in the listen mode. So all standby router will listen. So every 3 seconds, it should receive a hello from active router. If they do not receive a hello after 10 seconds, which means after 3 hello, they're missing 3 hello plus 1 second, and then that router will be changed into a active router. And then they turn into speak, which means they are sending hello now because they are in the active. Okay, that's all for HSRP. So how we are going to configure? So I hope you will do all the module practice and quiz inside our NetAcad. It should help you in order to memorize all the figure, all the facts regarding the number and so on if you do that. But we have our packet tracer activity, HSRP configuration 9.3.3. Okay, in this packet tracer activity, you will learn how to configure hot standby router protocol to provide redundancy default gateway. So we have a PCA and PCB, and we have two gateway, either through R1 or R3. But we are going to pick only one as active router at one time. We cannot use both. So we are going to configure HSRP active router and configure HSRP standby router and verify HSRP operation. So I'm going to show you how to do this now.